Welcome back to our next session. In this session, we shall discuss the sensor output types and the signals and in what form they are present in the output from sensor that we'll discuss elaborately. So we have seen the above topics. That is, in last class we have seen sensor calibration techniques, sensor output signal types. We will complete today in this session. In next session, we will see temperature and pressure sensors. So sensor signal output types, the sensors are crucial components in various systems, detecting physical parameters and converting them into electrical signals. These signals are then used for monitoring, control and processing in a wide range of applications. Sensor output signals can be in various forms. It includes analog, digital, pulse width modulation, current loop, frequency. Each type has specific characteristics, advantages, and applications. We'll discuss all of them. The first one is analog. Analog signals are continuous and represent information using a range of values. Typically, sensors produce voltage or current signals that vary continuously based on the measured parameter. Applications are temperature sensors, pressure sensors, and strain gauges. High resolution, simple measurement, and direct representation of measured quantity are the advantages of analog output. Disadvantages: susceptible to noise and signal degradation over long distances. So, transmission is a problem here. Next one is digital output. Digital signals represent information using discrete values, usually in binary forms, zeros and ones. Digital sensors outputs signals that correspond to one of two states or binary representation of a range of values. Applications: digital temperature sensors, proximity sensors, and switches. Advantages: less susceptible to noise, easy to interface with the digital systems, and often include built-in processing, that is signal processing. Disadvantages: limited resolution compared to analog signals, requires analog to digital conversion for certain types of measurements. Pulse width modulation output, these are the signals in digital square waves with variable duty cycles that correspond to analog signal levels. So here it looks like digital signals, but it can be mapped with the analog signals. That is the advantage with the pulse width modulation output. Applications: servo motor control, LED brightness control, fan speed control. Advantages: efficient signal transmission, especially for controlling devices like motors. Disadvantages: requires filtering to obtain a smooth analog signal. Complex signal processing is needed. So that is the major disadvantage. Current loop output. It is the current loop is a method for transmitting analog signals over long distances, typically using a 4 to 20 milliamp range. Applications: industrial process control, pressure sensors, flow meters. Advantages: immune to signal loss over long distances, can provide power to the sensor, easy to detect wiring issues. Whereas disadvantages: requires current loop receivers or converters for digital processing. So that is the disadvantage. Frequency output. Some sensors output a signal in the form of frequency, where the frequency corresponds to the measured parameter. Speed sensors, flow sensors, vibration sensors are few applications where we see frequency output. High noise immunity and suitable for long distance transmission are the good advantages. And disadvantages: requires additional circuitry to convert frequency to readable value. So frequency will is not in a readable form or useful form for recording purpose or for a display purpose, we have to convert it to some readable form. Serial output. Serial communication transmit data one bit at a time over a communication channel using different communication protocols like UART, SPI, or I2C, even RS-232. We have so many protocols. So applications, accelerometers, gyroscopes, environmental sensors. Advantages: supports complex data structures, allow multiple sensors to communicate over the same bus. Disadvantages: requires a microcontroller or computer to interface, slower than parallel communication. So it is slower than parallel communication. Voltage output. Voltage output sensors produce a signal that is proportional to the physical parameter being measured, usually in the form of an analog voltage. In thermocouples, RTDs, strain gauges, and other devices, we can find the voltage EMF or voltage as output. Advantages: simple to measure, provides a direct representation of the measured quantity. Disadvantages: susceptible to noise and voltage drops over long distances. Current output, it is current loop output, and it is industrial sensors, flow meters, pressure transmitters, less affected by resistance in wiring, robust against the signal loss over long distances, requires specific current measuring equipment. Resistance output. Resistance is another very popular transducting principle. Resistance based sensors like RTDs or thermistors change their resistance based on the physical parameter. Applications: temperature sensing, strain measurement, or humidity detection. Advantages: high accuracy, stable measurement over a wide range. Disadvantages: requires additional circuitry to convert resistance to a readable signal. That is the disadvantages. Frequency output. Sensors that output signals, frequency signals, do so by varying the frequency of the signal based on the measured parameter. Speed measurement, flow sensing, vibration monitoring. Advantages are easy to measure with the digital counters, resistance to noise. Disadvantages: requires frequency to voltage conversion for certain applications. Inductance output, it is very popular transducting principle. Inductance based sensors change their inductance in response to physical changes such as proximity or movement. Applications: proximity sensors, LVDTs, metal detectors, high precision, reliable in harsh environments are advantages. Requires complex circuitry for signal processing, sensitive to magnetic fields. So that is the major disadvantage. Capacitance output. It is another popular transducting principle. Capacitance based sensors measure changes in capacitance due to physical changes such as pressure or distance. Applications: pressure sensors, proximity sensors, humidity sensors. Advantages: high sensitivity, good response time. Affected by environmental factors like temperature and humidity, requires a stable reference capacitance. So these are the disadvantages. Next is impedance output. Impedance sensors measures the combination of resistance and reactance often used in AC circuits. Applications: bioimpedance measurement, material property sensing. Advantages: comprehensive measurement of electrical properties. Disadvantages: complex measurement and interpretation, requires precise calibration. So these are the disadvantages. Next, power output. Some sensors output power representing the energy being transferred or used, typically in the form of electrical power in watts. Applications: energy meters, power monitoring, solar energy sensors. Advantages: direct measurement of energy usage, whereas disadvantages: require simultaneous measurement of voltage and current. So these are the disadvantages, and these textbooks you can follow for most of the topics on the e-resources. We stop here, students. Thank you. In next session, we are going to see the temperature sensors, temperature and pressure sensors. Thank you. Thank you, students.